Hello everyone, greetings. This is Vignesh, working as an assistant professor in Department of Mechanical and Mechatronics Engineering in SNS College of Technology. So, welcome to my new lecture series. In this lecture series, we are going to discuss about the basics of civil and mechanical engineering, and that too particularly in civil engineering. So, today we are going to talk about or discuss about the basics of surveying. Okay, so surveying is both an art and science focused on accurately measuring distances, angles, and positions across or beneath the Earth's surface. So, for example, if I want to measure the height of a building, or if I want to measure the area of a particular land, it is called a surveying. So its primary objective is to determine the relative locations and elevations of points, which are crucial for creating precise maps, plans, and technical drawings. For example, I'm having a land of one hectare. Okay, so I want to actually I want to measure that it is actually an 1 hectare. So what the method used to uh, measure the area, measure the relative points on the earth surface is called survey. Okay, so these are very crucial because whatever the constructions that has been made, it's only because of surveying. It is kind of the first step when you're trying to build something kind of an infrastructure. So these outputs are indispensable for a wide array of applications, including engineering design, construction project, and effective land management. So, for example, surveying plays a fundamental role in urban development by establishing precise control points that guide the exact layout of roads, railways, and buildings. So, without the meticulous measurements provided by the surveyors, complex infrastructure projects would lack the necessary spatial accuracy for successful executions and long term stability. So, in general, the surveying concepts are introduced in India after the British period. Okay, so they lay the foundation of train routes, etc. For those, laying of train routes, etc. This surveying plays a vital role. Okay, so in general, for example, if I want to construct a railway line, okay, or a bridge or something else, so the surveying, the it is called as a in surveying it is technically called as a benchmark. It is a reference point, if I want to say that. So based on the previous reference point, these new reference point will be created that will be act as a benchmark for the next construction project. Okay, so the first benchmark would be, I say, the Bombay port. Okay, so it is the first benchmark of India. From that, all the reference point has been taken out, and for us, nearby railway stations, bridges, overhead water tank will be act as a benchmark for the next construction phases or new phases. So if surveyor goes, okay, he won't go to the Bombay and take that benchmark value. Okay, he takes the nearby benchmark value, set it as a benchmark, and he will measure those uh, uh, relative points on the earth. So there are two types of surveying is there. One is plain surveying, another one is geodetic surveying. So plain surveying operates under the assumption that earth surface is flat. Okay, so without considering the original earth surface, we assume that earth surface is a flat one, and this simplification is suitable for smaller areas, typically less than 200 square kilometers. So where the curvature of the earth has a no negligible effect. Whereas if you want to construct a dam, okay, we need to consider the curvature of the earth. So that surveying is called geodetic surveying. In contrast, the plane surveying, geodetic surveying meticulously accounts the earth's true curvature and shape. So this method is employed for large scale project covering areas greater than 200 square kilometers or whenever extremely high precision is required, right? And in plane surveying, the focus is on relative positions within a confined area, whereas in geodetic surveying, the focus is on a high level. Okay, so its three-dimensional reality is very very critical, but in a smaller project, in cost-effective method, plane surveying can be used. For a high-level project, geodetic surveying can be used. And the fundamental principles, there are two types. One is whole to part, that is, see, if I have a piece of, a certain area, okay, what I will do, I will cut into 8 pieces, right? So after that I will take one by one. Okay, so the whole pizza can be cutted into 8 pieces, so it is called as a whole to part. Okay, so this principle dictates that surveying should always begin by establishing highly accurate network of control points covering the entire area of interest. Yes, and then these area of interest can be divided into small parts, and those small parts can be uh, you know uh, measured very very effectively and precisely. So this is a whole to part, but it takes time. It takes very much slower time, because of to maintain the accuracy and control, we need time to do this part, that is whole to part. And two independent measurements, it is like fixing one point will be dependent by the two independent points. Okay, if you consider a triangle, right? So triangle, we have 3 points, three connecting points. So in that, 2 points are fixed. Based on the 2 points, another dependent point can be fixed on the either side of it. So one will be a linear measurement, another one is an angular measurement. So it will be it helps identify potential mistakes and improves the reliability of survey data. So it helps the overall precision, because we know that where the mistakes can be done in fixing those 2 points. So adhering to these fundamental principles is paramount in surveying. They form the bedrock of accurate data collection and error control, ensuring that results are reliable for all subsequent engineering and construction and mapping application. And eventually maps are developed by these processes, only by the surveying. So surveying is very very essential in whatever the construction we needed, whatever the land measurements that we are doing, whether the building is in height or low, whether the altitude. If you travel to the Ooty, for example, if you travel to the Ooty, we can say that this point is above the sea level, that is some 1200 meter above the sea level. You can see the boats, right? So those boats are kept only by doing these kind of surveying. Okay, we can effectively measure those heights as well. Not only the land, we can effectively measure the altitude as well. So that is called leveling in surveying. And key surveying methods, one is chain surveying. It is used for low area measurements. And compass surveying, it utilizes compass for angular measurements. Theodolite surveying employs the theodolite for precise horizontal and vertical angles. Plane table surveying are there, aerial photographic surveying are there, remote sensing are there. And instruments, as we say that in chain surveying we can use chains, and in compass surveying we are using level and rod, station points, etc. And nowadays we are using drones as well. As the technology are improving, we are using drone and GPS technology to without needing of more manpower. These drone and GPS technologies will effectively improve the uh, surveying techniques, and those measurements can be accurately kept, and which is very very critical for the success and safety of engineering projects, infrastructure development, and land management worldwide. So these technologies are continuously evolving, we are also continuously evolving too. And this is Vignesh signing off for surveying concept. Thank you for watching.